Welcome, everybody. I'm Jeff Bercovici. I'm a business editor at the Los Angeles Times, and I run our technology coverage there. I've written a fair amount about the future of food, clean meat, and cell-based protein. That's why I'm here, but you're much more interested in my panel, so I'm going to quickly introduce them and then ask them to tell you a little bit more about themselves and what brings them here. To my left, first we have Michele Fite. She is the Chief Commercial Officer at Motif FoodWorks. To her left is Thomas Jonas, the CEO and co-founder of Sustainable Bioproducts. To his left, Mark Matlock, the Senior Vice President of Food Research at Arthur Daniels Midland Company. And all the way over, we have Anja Schwenzfeier, the Business Development Manager at Novozymes. So just real quickly, round robin, why don't you just tell us a little bit about your company and what their connection is to this topic we're talking about, which is moving beyond plants to use fermentation and organisms, fermentation, fungi, algae, and bacteria to create novel plants and ingredients.
That's great. Thank you, Jeff. So hi, everyone. I'm Michele Fite. I'm with Motif FoodWorks. We're an organization full of food lovers. We have food experts and food scientists who are working to unlock the secrets of food. So our mission is to understand those secrets of food so we can work with food innovators and understand what consumers and plant-based foods are demanding now so that we can produce ingredients in a responsible way and not have to worry about sacrifices in taste or in nutrition and solve those solutions for consumers. All right, Thomas, over to you.
Thanks, Michele. So Thomas Jonas, I'm the CEO and co-founder of Sustainable Bioproducts. We are a food company. We started as a research project for NASA. We were trying to figure out if NASA was to send a probe to a moon of Saturn, what would be the condition in which it would make sense to look for life. So that took us to exploring the backcountry of Yellowstone National Park, which, as you may know, is the biggest supervolcano in the world. And so there are some very interesting life forms that evolved there in this volcanic acidic spring, microbial life form. And what we do is we developed a novel fermentation process to cultivate them. So we farm those microbes.
I'm Mark Matlock, Senior Vice President of Food Research with ADM. Is my mic working?
I think you're cutting in.
Oh, all right, thank you. Hello, I'm Mark Matlock, Senior Vice President of Food Research for ADM. ADM has been a company that's been making meat analogs since the 1980s. We invented textured vegetable protein, basically putting vegetable protein through an extruder back in the 1960s. In the 1990s, we did a lot of work on fermentation. And so today, to take some of those plant proteins and add some of the amino acids to them that are needed for complete nutrition. We make amino acids like lysine and threonine, but we also make things like xanthan gum that provide the texture. And so our interest in this is basically producing proteins with fermentation capabilities, but also combining that potentially with plants and getting the best of both in many different things. To that, we've also added a flavor company, Wild Flavors, back in 2014. So again, people, one thing that's been very clear through this whole thing, if it doesn't taste good, people aren't going to be a repeat buyer. So that's very important to match the matrix to the flavor system. Thank you.
Okay, so yes. Okay, so hello everybody, pleasure to be here. My name is Anja, I'm working for Novozymes. We are a biotechnology company based in Denmark, and we happen to produce proteins by fermentation, I think, for more than 50 years already. But up until now, these proteins happen to be catalytic proteins, aka enzymes. But of course, we have a big R&D body and also the production capabilities to produce proteins by fermentation, now with the focus on enzymes. But we are starting to explore other options as well. So happy to be here in this discussion.
Great. I want to start by bringing this idea of fermentation down a little bit, breaking it down. Thomas, you were talking about the idea of Am I out now too? Thomas, you were talking about the idea of fermentation as being a new form of farming. Can you spin that metaphor out a little bit and talk about, in what way this is a transition to a new era of farming?
Sure. So fermentation is really cultivating microbes. Mm-hmm. And it is incredibly efficient. Microbes, as you guys know, duplicate very, very fast. So when you think about the doubling time for a cow or a pig or a goat, you're talking about years. You're talking in years. And not just the replacement, but the doubling. When you talk about microbes, you're talking about hours. You're talking about hours, and you're talking about something that's also very important here is you don't have what I call the fixed cost of life. So if you think about a cow is standing up, a cow is breathing, a cow is emitting heat, doing all these things. A microbe doesn't do that. So a microbe is just doing what you want the microbe to do. So in our case, the microbe that we use are 50% protein, complete protein, just like egg, just like meat, all the essential amino acids are there. It's a filamentous organism, so it creates texture. It kind of mimics muscle filaments, if you will. Our growth season is 365 days a year. So we are disconnected from this cycle, for this constraint that you typically have when you think about more classic form of agriculture. This being said, this is nature's technology. So nature is really the #1 biotech engineer in the world. I don't think anyone is going to debate that. And our organism is a naturally occurring organism. We're creating conditions that are optimal for itself, but it is really this next generation of very efficient farming. And I think what we want to get through farming is the nutriment that we need for our food. And microbes can do that tremendously efficiently. And again, I think the notion of efficiency, as we are thinking about the environment, as we are thinking about really, I mean, the challenge to our industry is how do we do more with less? We're going to have way more people. How do we do more with our food with less? And it's all about the efficiency, and microbes are extraordinarily efficient.
And I think I'd like to add to that, because efficiency is, of course, one big plus, but the other one is that you can be incredibly specific. So, and this is also, for example, compared to plant proteins, which are great, don't get me wrong, but if you need one specific ingredient, this is what microbes can provide to you without really an extensive downstream process or modification that might be needed for, if you go towards plant-based products. I think that's another plus to add on top.
So I think that's a fantastic segue into the impact that efficiency brings to the sustainability, to the environmental impact as well. So there's a great article recently in the New York Times referencing the Journal of Scientific Reports that talked about, just here in the US alone, that if we went to a more efficient agricultural system, talking about how much we all eat in terms of meat, 215 pounds a year is what the average US consumer consumes in terms of meat. And if we could reduce a quarter of that through plant-based eating or whatever other choices we made, but if we reduced by a quarter the kind of impact we could have on the environment. So it equals, I think if I remember the number correctly, 82 million metric tons of reduction in greenhouse emissions. That also opens up, so I'm going back to Thomas's comparison to the efficiency and comparing it to animals. That quarter reduction also frees up 32 million acres of quality agriculture land. That's the size, just to give you a comparison, that's the size of the state of Indiana. So the power of going to a more efficient agricultural system, what the biological engineering does in this case, and the impact it has on our environment. That's why we get very excited about the business that we're in and the impact that we can have in this industry.
So let's talk. You brought up plant-based food, plant-based meat. What are sort of the pros and cons? If you need to get X million pounds of protein to feed Y billion people, what are the advantages of doing it through fermenting microbes versus some of the other approaches that we're here talking about today?
So one thing to remember, in agriculture, plants are more efficient at producing carbohydrates than they are typically of producing lipids or producing proteins. So what we're really talking about is converting some of these excess carbohydrates that the plants are producing in excess of what we need to proteins directly through a step that's called fermentation. So that's really one of the key things here, is we're making more efficient use of the agriculture systems that we have in place.
Gotcha. Okay, so the microbes are your force multiplier of turning sugar into protein.
So if I have excess sugar, and what I'd really like to have is more protein, this is a mechanism to do that.
Mm-hmm. So think about it this way. If you think about texture soy, texture pea, which has been the backbone of this first wave of technology that we've seen over the past few years, what you're really doing is you're extracting the protein fraction from a soybean, from a pea, and then you have this protein flour that you processed out, and you have to rebuild the texture and bring back the moisture, right?
Mm-hmm.
But I think, Jeff, you also have to see it like this. There are two different types of proteins that you need in food technology, right? So one is the bulk that you do your burger patty with, and one is specialty ingredients or proteins that have a certain functionality. And you can produce both by fermentation. The question is, do you want to produce both by fermentation? I think you will always have plant-based proteins, and you will have proteins by fermentation, but it's about finding the best combination of those two. And if you look at food technology right now, like functionality-wise, everything that we have in our toolbox is historically based on animal-based proteins, right? So egg is incredibly functional, milk is incredibly functional. So to see, okay, how can we actually maybe exchange those while keeping the bulk, maybe plant-based, that's also, I think, a nice way, a nice toolbox to play around with. And I think fermentation just adds you a nice additional tool to that.
Just one thing I'd like to add to this point is, so once you have, again, to get back to the efficiency idea, and the real challenge for the planet is not going to be, are we going to have enough oil? Are we going to have enough carbohydrate? It's going to be, are we going to have enough protein, right?
Exactly.
So once you've extracted the protein flour, it's going to be more efficient when you're in a plant-based. What we can do is we can take the carbohydrates that are left, and then we create protein. We create protein just the way a cow creates protein. And in a context where we have to think about rare resources, and where the rare resource is going to be protein, I think having these technologies that really create protein without having to plant an additional grain of soy anywhere, without having to do any additional use of the field, I think that's very interesting.
Yeah, the vast majority of cereal crops and of oilseeds are basically being used to feed animal agriculture. So all we're talking about is shifting a small portion of that to a more efficient production system. And it can grow with what the demand is.
So to Michele's point, I want to bounce back on the point you were making about making the land available. So we are scaling up our technology in Chicago, and we're actually going to be in the old meatpacking district in Chicago. Things happen. In the stockyard in Chicago, where literally meat from all of America historically was processed. And we're going to be using about 0.7 acres. In terms of burger equivalent, the number of cows that you would have to feed, you would have to use about 7,000 acres of land, of grazing land. So we're freeing land, to your point, we're making that land available to repair the planet, regenerate the planet, and I think those things are, again, in the context of our current situation, climate change, and those things are absolutely critical. We need to do these things. We have to do these things.
And is that factoring in the land use to create the feedstock for your organism?
So No, I'm just talking about the grazing part, but we are capturing feedstock, the portion of feedstock that is not really being used, right? So there is no additional need.
It's being used, but it's being used primarily by animal agriculture. You know, about a third of the corn crop is basically fed as feeds.
Right.
So if you take the carbohydrates from that, and in fact, you know, today a lot of the biofuels industry that people have criticized about food, it's really making an efficient use of those carbohydrates to lower the cost of the protein co-product. If you had to throw that away, I mean, the protein would be very expensive. So we have different ways of utilizing it. This is a new way of utilizing it that produces a protein directly.
Gotcha, okay.
And then to the other point that Anja was making, you can also make specific proteins that have properties that you need to make certain things. So if you need a protein that's going to provide a binder to hold some of this together, you could produce something like that. If you need one that provides fat emulsification, you can generate a protein that's going to have that type of capability.
Okay. Can we talk a little bit about nutrition and health profiles of fermented proteins? What sort of special qualities can you put into food that you ferment in a bioreactor versus either deriving it from plants or raising it and slaughtering it on a feedlot?
So, go ahead. Do you want to answer? Or you want me
Go
to
ahead.
jump
Go
in?
ahead.
So in our area, in our company, we are working across a number of microbes in order to address sensory attributes, taste, smell, the flavors, the textures, and we are also working on nutrition profiles so that we can help raise, so you don't have to compromise taste or nutrition when consumers are looking to access plant-based foods. So there's a lot in searching all those microbes, all those proteins, fats, carbohydrates. We're looking across all of those so that we can continue to work on raising the nutritional profile. So there's no sacrifice that you have to make.
Okay. Did you have something to add there?
Well, one thing I would add is by fermentation, it's not only necessarily proteins that you can make, but for example, we also produce algal DHA. So if you're trying to make a salmon analog and you need to supplement the DHA that the salmon would normally get from the little krill shrimp who get it from the Schizochytrium algae that they eat, we just bypass all those middle people and put ferment the DHA, and you can put that into the meat analog. So to the nutrition side, you can through fermentation produce a lot of the different things that you might need to provide that total balance. Okay. It could be vitamins as well.
Exactly.
And let's talk a little bit about where consumers are all this, where you're meeting consumers, because I think in earlier sessions today we were talking about this sort of evolution of consumer attitudes toward their food, which in some ways are really driving them very quickly to embrace meat alternatives. But in some ways, there are some counter currents in terms of people wanting to eat, whole foods, natural foods with no ingredients or fewer, short ingredient lists. So, where do you either in your research you've done or just kind of anecdotally, where do you find consumers are on the idea of basically eating, fermented proteins, fermented meat alternatives?
I think the funny thing is if you look into the history of food technology again, fermented foods have been there for centuries already. Just think about beer.
Yogurt.
So all those things are fermented.
Anybody in this room has drunk beer? Raise your hand. Anybody has had cheese?
No,
raise your hand. So, sorry, I think what's important is to understand that those products have been around. Kombucha, people embrace kombucha. All those products are fermented. Without fermentation, no wine, no beer.
Right.
It would be a pretty sad world, right?
Right. So I will jump in here because we just at Motif just finished conducting proprietary research on this very issue. and specifically on meat alternative users. And so what we found is those that are currently buying, so first of all, they're buying because they believe that plant-based foods are healthier than red meat, and they think it's even healthier than chicken is for them. So they want to be in this space. And then they also believe it's sustainable, it's better for the environment, and it's better for animal welfare. But they believe it's nutritious, and that's why they're in this space. And they are open to technology helping to solve that issue for them, solving it based on providing healthier products for them and providing the solutions that have an impact on climate change. So these consumers are more open to technical solutions than consumers that are a lot older like me have been in the past. And so we're seeing in our work that there's a gateway for these consumers to technical advancements. And because they believe that it aligns with their values. Our belief is that we as an industry have a responsibility to them and how we communicate to them and talk to them and share that information. And so we want to work on that and share it in a transparent way and be open and make sure that how we talk about it aligns with their values, how it impacts in terms of climate change, share good information on that around good LCAs, and that it's peer reviewed and things like that. So that's the kind of thing we're working on with our partners here in this industry.
Yeah, we're actually conducting consumer research right now. So we've had quite a few panels, and we're talking to consumer exactly around these things. And candidly, I have been flabbergasted by the level of acceptance that we did not expect. And I think it's interesting because if you look at the curve, for instance, of adoption on things like plant-based milk, you see that the countries which were the last to have plant-based milk come to them are the ones that are adopting it faster. And so the adoption curve becomes shorter and shorter and shorter. So I think people have been using plant-based alternative for a while now, and it's kind of mainstream. I mean, I think we live in a world of Beyond and Impossible and all of these guys, and I think the consumer, they check the box. Yeah, sure, it's plant-based. I get it. Right. I cannot open a newspaper without reading an article about these guys. So then once you've established that, it's the next thing, but it's not very different. It's not very shocking. And I think the notion of microbes is also something that has evolved over time. And people, I mean, look at kombucha, right? People think about microbes as something positive, as something that's good for their guts.
Absolutely.
They understand microbes are friendly. I mean, there could be some bad ones, but a lot of more microbes are friendly and good for us than are actually bad.
And I think also, I mean, of course, I used the example of beer, right, because it's there for centuries already, but you can think also there are processing aids that are used in food technology that are basically known to everybody. So if you want to make lactose-free milk, you need an enzyme, and the enzyme is produced by fermentation. So it is already, so to say, commonly used in food technology. I think there's just a new consumer understanding that raises more awareness these days to those topics. But so to say, if you're in the industry, it's so to say a technology that is already well known. So it's not that we are doing something new, so to say, for us.
Right, because you could buy fermented meat alternatives. I mean, corn you could buy in a grocery store 30 years ago, but they weren't. It wasn't sort of a marketing advantage to talk about it as something that was fermented, whereas now it almost seems like to say, we produced it through this new process is a net positive. It actually generates some consumer excitement rather than being like, whoa, what's this weird stuff?
Right.
Correct.
Exactly.
I think it's really interesting, tomorrow's all about cell-based meats. And so, when you think about a food that's produced that way, I mean, it's really, and that the consumers are embracing these concepts. To me, it's really refreshing to have, some consumers who are embracing technology to this degree. It's, and to the extent that they may lead, the mainstream their direction, that's a very positive thing because at the end, we've got to utilize every tool that science brings us in order to meet the needs.
Can we talk a little bit about the business of building a company around producing fermented proteins? So there's the ingredient route and there's the branded route. Can we talk a little bit about the advantages of going either way or both ways, as may be the case? This is probably one that for you, Thomas.
So we have decided to take a route which is a B2C route. We're going to start with B2C. We have a product that's very versatile, so we can do meat type of texture and flavor. We can do dairy type of texture and flavor. We can do sweet. We can do savory. So we're not going to be doing every single possible thing that can be done under the sun that requires protein. So we want to partner with the right people on some of this vertical, and we want to do some of them ourselves. I think it's important for education purposes when you bring something new to be telling that story. We think we have a great story to tell. We think it's a story of hope in the sense that we're bringing this new solution. We want to build that with our friends and partner in the microbial field. It's important that we tell that story right, and then we want to be able to work with the people who are trying to have more impact and distribute this solution as widely as possible. The impact aspect is really critical. I mean, what we are doing needs to have an impact. I think we all feel very strongly about that here.
Mm-hmm. And I think Thomas is raising a really important point talking about partnerships, because as Novozymes, we clearly have a B2B focus, but we realize, of course, that it's important to educate consumers and to make fermentation, so to say, a commonplace. It is important to have consumer products that we might not produce ourselves, but it's so important to work with the right partners to make that happen. And I think, nevertheless, which route you choose, if it's B2B or B2C, I think it really requires strong partnerships in the field to make that happen.
We're going to go to questions in a minute. I see that we're getting some great questions coming in already, but just for anybody who hasn't tweeted a question, we are, I'm looking at a good list here, and we will definitely try to budget a few minutes to get to them. But before we move on to that, let's quickly discuss regulatory issues. What would be the sort of ideal, regulatory framework to making this happen as quickly as it needs to happen, as quickly as you'd like to see it happen? Are there any, what's on your wish list, or what do you worry about?
I can say a few words about what we do. I think, look, I know getting into FDA bashing is people like to do that. I'm not going to do that. I think FDA is great. Mm-hmm. I think they are very smart people. I think we've had discussion with the FDA. By the way, I'm not saying that just because we're having discussion with the FDA. Look, I think there are people who understand that it is important that the regulatory enable this solution to come and happen. They understand because those are matter of public policies. We understand that global warming is going to have an impact on the way we grow our food. If we don't have technology solutions that enable us to complement, supplement, and really guarantee that our food supply will be there, that would really be a shame. So we've been working with the FDA. We intend to be GRAS. I think the GRAS process is a common process.
Mm-hmm.
Yeah, I would just say, the FDA is a very rational organization. They're focused on food safety, and the procedure of GRAS self-affirmation that's been in place for some years, is a very straightforward process. It's interesting, if you look up GRAS number 1, was actually to ADM, and it was a lot of fun for us to kind of pioneer through that regulatory process. But it's rational. And so you do what's needed to be done. You do the toxicology tests that are needed, and you know, it's predictable. And that's what we really need in industry, is a predictable process that we know what we need to do, that there's no surprises.
There is a question on here that I wanted to ask, but somebody in our audience asked it a little bit better, which is food safety. How do you think about food safety for proteins that have never before been part of human food consumption? I mean, are there allergenicity issues, for instance, that you have to be mindful of?
I think generally you can say if you're working with proteins, they can be an allergen for certain people. This is what proteins are, right? But again, I'm coming back to what I said earlier. You want to produce specific proteins that might already exist, but you want to do that more efficiently and more sustainable. So then, of course, you deal with molecules that you're already familiar with. So there you know what kind of allergenicity profile they have. And I think Thomas can speak better for when it's about fungi, but I think even for fungi we know quite a lot already, because they have also been around for quite some time and have been consumed already for quite some time. So for me, it's not so much about creating a completely new protein that might be in the future, but right now we're really looking in how can we improve ingredients that we currently work with by fermentation.
Right.
And there you know, so to say, the allergenicity profiles typically that you deal with, and there are processes in place to check for that, if you go through your development processes.
What are the biggest challenges? What are the biggest challenges in what you do? You know, if you identify a food product that you think you can improve or through fermentation, what are the challenges from the moment you start to the moment you get it to market?
For us, the biggest challenge is how fast can we identify the new microbe and bringing that up to a scale. How can we scale that to the level so we can produce it at the level we need to, at the expression levels that provide the accessibility, the cost targets, the applications that we can develop that in, so it's in the right formulations that our customers want it to be in, so it works within the ground beef patty at the flavor that this customer wants it in. So those are the kind of processes that take a lot of time and a lot of engineering, a lot of work with our food scientists to understand how their processes work. That's the scale up and the targeting that we have to get to that takes quite a bit of time.
Can I just can I just break that down a little bit? Mm-hmm. What is it about the scale? I mean, we're talking about organisms that reproduce vastly faster than plants or animals. Mm-hmm. So I would think that the scaling would be as rapid as you need it to be. What are the chokehold?
It's in the development process though itself. So the R&D process of finding those microbes and then ensuring that their quote expression level is to the cost targets, and then scaling them up to the level so you get the volume that you want them at, and then ensuring that they work within the right application. So it's just about formulating them to make sure that they taste exactly the way that you want within that specific product that you're trying to make it within. And so that's just a typical R&D timeline. So that would be no different than whether you took that from a cow or whether we're developing those from a microbe in recombinant DNA and then fermenting that. And that's the challenge in terms of the timeline.
Yeah, and Jeff, everybody, I think whoever tried to scale up something from laboratory scale to industrial scale,
right.
I mean, there are different steps that you have to take that this is quite a challenge.
Right.
So if you go from a shaking flask on your lab table towards industrial size fermenter, there are quite some hurdles that you need to take.
Right.
And I think this is, for example, something that we see in our production processes, because this is what we do. This is our bread and butter. Right. So we have process groups that work on it, but these guys they don't run out of
exactly.
work, because it's not as like you just put them in a bigger shaking flask on industrial scale and they just do what they do in like small scale.
One other thing I would say is, if you're in a B2B platform and so you come up with a new ingredient, okay, the development time there, a lot of times getting your customers to put it into their products. And the really interesting thing about that is the startups have really turned that a little bit on its head.
Right, they
because
have.
we've had ingredients where, you know, it's been very slow uptake. Then you have some startup that builds a business around this new ingredient, and then all of a sudden, you know, they create a market that didn't exist before, all built around that particular ingredient. So I think that startups play a key role in some of this, how fast things get to market, especially in that B2B, if that's your model. By doing B2C, I think you're sidestepping that a little bit and getting it in front of the consumer faster than if you had to convince you know, CPG multinationals to basically develop a product around your ingredient. But they're catching on, and they're much better at it than they used to be.
On the scaling topic, we have a question from the audience that speaks to that, which is, does scaling fermentation technologies require GM organisms, and to what extent is that a barrier to capturing markets when you're using GMO-derived products?
So in the case of what we do, it is a natural organism. Again, I mean, we're using an extremophile organism, so an organism that has phenomenal resiliency capabilities, that comes from a very barren environment and has developed really unique strategies. And again, it's really nature technology. It's how nature grows in an environment where the resources are limited. And we learn from that, and we develop our technology based on that. It is a natural product in that sense. It's completely native. We're not doing GMO. I think, and so I think people need to revisit the notion of GMO. We don't have the time to be dumb about these things. You know, we cannot be anti-science about these things. I like to say that GMO is cut, copy, and paste. And again, I'm talking for these guys. We're not doing GMO, but I think we have to be smart. We have to use science for what it can do. It's the most hopeful tool that we have to address the challenges that are in front of us. And we don't have the luxury of being coy and being dumb about these things. It's one of the most phenomenal tools. It's the blueprint of life. So it's a tool. It's control, copy, and control and paste. And cut, copy, and paste. You can cut a piece of DNA, cut it there. You can do terrible things. You can do wonderful things. It's our decision. And I think the new generation of thinking around the new tools, I think people are thinking around these things with much more ethical perspective than arguably it has happened in the past.
And I think there are two approaches, right? So we have been talking a lot about efficiency. So of course, a GMO can help to increase efficiency of an organism producing potentially a natural molecule that then you're gonna use. But you can also use what Michele was talking to. If you say, I use actually selection, and by selecting the right organisms that can be a natural one, I also can reach a high efficiency. So the nice thing about fermentation is, no matter, so to say, what are you aiming at, I think both is possible.
Mm-hmm. So sustainable bioproducts, you found your organism by basically preparing for an expedition to Mars, which doesn't seem like the most efficient way to go about discovery. What kind of innovation is happening around either discovery or engineering of organisms to make foods that are, you know, more efficient, more delicious, more nutritious? Is there an answer to this question?
I think
anybody.
Well, so I mentioned algal DHA earlier, and you know, we were faced with this situation. If you want to sell this in Europe, where a lot of the aquaculture feed market is for something like an algal DHA, we needed a non-GMO organism, but the you know, productivity was too poor to be economical, and so that was done with basically classical mutagenesis, but using high throughput genomic sequencing to sequence every single mutant till you get to the place where you want to be. So again, these tools can be used in different ways to get to different things, but that allowed us to get to the point where we could produce that economically with a non-GMO organism.
Right.
But you know, it would have been much more straightforward to use the tool.
I think the science, again, is, look, as I mentioned earlier, we started as a research mission for NASA. We were awarded, as we grew up, a lot of very prestigious grants from National Science Foundation, from the EPA, from the USDA. I mean, our science is very real and very solid and very breakthrough. We have to use science. We have to be smart people. We have to all collectively understand these things and leverage the tools that we have. It is important. We are a very smart, we are the smartest creature on the planet. Let's demonstrate it. And let's use that for the benefit of this planet and for the benefit of our descendants, who we just borrow this land from.
I have a question specifically for Michele. Motif, which is a new company, started this last year, correct?
In March.
Sorry.
March of this year.
Wow, it's been a long year. Is the focus at Motif creating new to the world proteins, or is it more about creating existing proteins more efficiently / sustainably?
So someday we might be creating new proteins, but we are focused right now on creating known proteins to solve for, as I was mentioning before, around taste and texture and smell and functionality and sensory attributes. So it's known proteins, animal-free proteins.
Gotcha. Here's a question I kind of like. We'll put on our prediction hats. What does an American dinner plate look like in 2040?
Oh, I think that.
How much of our meat is still coming from animals?
That's a tough one to answer. So what we're seeing and what we're hearing when we talk to consumers is that you have a rush. I'm sure all of you are experiencing this and seeing this. You have a rush of people coming into this space who want to be a part of it. And for a number of reasons. One, they believe in their heart that plant-based eating is better for them. And they want multiple options. We're talking a lot about meat and meat alternatives, but you see the penetration increasing in yogurts. And I heard somebody quote milk at 13%. Guys, it's up to 19% in the US here this year. So, and of all milks. And you see the penetration growing in yogurts and in ice cream, and it's happening in cheese. And so they're rushing everywhere, and it's growing and growing. It's because of health, sustainability, animal welfare, and because it's a badge. I want to be part of this trend. So we believe at Motif, and our investors and our partners that we're working with believe this is not just right now, but it's the way consumers, their values are changing, and so that the dinner table is going to look very different. Our position at Motif and most of our investors, we don't believe that animals are going to go away, that it's the end for animals, but that this is part of how we're going to eat and how we're going to change how we live. The danger for us is if we don't make the products more palatable and easier and accessible for consumers. And the accessibility includes cost. And so that's one of the things we're working on is how do we, and it's one of the challenges, the scale up, is how do we make this more affordable? So right now, we all know in the milk world that milk, that plant-based milk still costs, what, $3.99 for that half gallon? And at Walmart, you can get that gallon of milk that animal milk for 99 cents. And so the price pressure is going to come, and if we want to make this more accessible, we have to address the cost as well. And so those are the kind of things that our technology that we're working on, and in time, we have to work on nutrition, the taste, so we can keep bringing in more consumers into this space and address the things that Thomas is talking about in terms of sustainability and climate change and accessibility. So it's not just those of us in the highest echelon of the socioeconomic stratosphere that can afford plant-based eating. So those are the kind of things that we're working on hard within our organizations and in this nascent industry to address.
Yeah, and I like to summarize this not in a prediction, but in a hope. So
Yes.
for me, if you translate that if you look at the plate, that it will be plant or fungal-based products, with great quality, which is enabled by fermentive ingredients. This is how I would like to phrase it.
That's great.
And quickly, because we only have a minute left, but what's standing in between you and cost parity with meat right now? I mean, you know, we've been talking a lot about efficiency. When does that virtuous cycle kick in, where it's suddenly like cheaper to, you know, get a pound of fungal?
I think it is kicking in already.
That's the scale up, the work, the R&D that we're doing and driving now. And so over time, we get better and better at this, and the technology improves, and we get closer and closer.
Well, thank you. Thank you so much for the great discussion. Thank you, everybody, for your questions, and thanks to the Good Food Institute.